In this video, we will develop a program for sorting an array with AlgoTouch. The method used is called selection sort. The method consists of to place at index I the smallest value found in the table starting from position I, to advance I one cell, place in I the smallest value found in the table starting from I, and so on until the array is completely sorted. In our example, we must reverse 50 and 10 using a variable like TMP. Move I forward one cell. Reverse 40 and 20, always with TMP. Move I forward one cell, and continue until the table is completely sorted. For this program, you need two loops, one nested inside the other. In AlgoTouch, each loop is implemented by a macro. Fissert, we return AlgoTouch to its initial state. We start with the placeMin macro, whose role is to place at I the smallest of the values in the array starting from position I. To browse the array from position I, we need a new index j, which we position at 1, the cell after I. We first generate the general case, the loop body that we select in the code. We put AlgoTouch in recording mode. In our case, AI is worth 50 and AJ is worth 40. These two values must be reversed to put the smaller of the two in AI. We must compare AI and AJ. We choose AI greater than AJ, and we invert the two values with TMP. As we only have this inversion to perform, we close the dialog box corresponding to this case. In the code, the alternative is added, if AI greater than AJ. The else is to be done, to do. It remains to check whether the next cell does not have a smaller value by moving j forward one cell. The loop body is complete. We can stop recording mode. We run the body by selecting loop body in the code and clicking the green triangle. AlgoTouch tells us that we have not processed the cell AI, less equal to AJ. Here 80 is greater than 40. The two values should not be reversed. In fact, there is nothing to do. Just close the dialog box. In the code, the else to do disappears. We run the body in build mode again to look for the smallest value. The index j leaves the table. You need to exit the loop and generate an exit condition. Select exit conditions in code. Place AlgoTouch in recording mode. On the comparator, we place j and len a. Among the three choices proposed by AlgoTouch, we could choose j equal len a. But we prefer j great equal len a. The exit condition is added. In the Python code, it is the continuation condition j smaller than len a, which is added in the while. There remains the initialization, which consists of positioning j at I plus 1. The code is now complete. We stop recording mode. We can test the macro by advancing I by one cell of the array and running the placeMin macro by clicking on its black triangle. It's correct. We perform a final test with I in 2. It's correct. Let's now move on to the external loop, the selection sort macro, which we select by clicking on the workspace. To begin, we right-click on the array A to mix the values. And we place 0 in I, the first cell, to place the smallest value. As before, we start with the loop body that we select in the code and put AlgoTouch into record mode. The first operation to perform is to place the smallest value at I. This is done with placeMin. Now we must move on to the next cell by increasing the value of I by 1. The loop body is complete. We stop record mode so we can run the loop body in build mode with the green triangle. The array ends up being completely sorted. The index I is on the last cell of the array A. We could run the loop body again, but it's useless. We have to get out of the loop. We are missing a variable to tell us that the penultimate cell in the array. We create IEND, which we position at len A1. We can now add the exit condition. Select exit conditions in the code. Put AlgoTouch in recording mode. Drop I and IEND. Choose the condition I greater equal IEND in preference to I equal IEND. The exit condition has been added and the continuation condition I less equals than IEND has been added to the while of the Python code. It remains to add the initialization. Set I to 0 and IENDAT len A1. The macro code is now complete. We stop the recording mode. We can test the selection sort macro, but first we shuffle the values in array A again. Running the macro sorts the array correctly. We can see the complete selection sorting code in Python in the console part. The internal placemin macro has been replaced by its code. We thus see the interweaving of the two loops. This Python code can be copied and used in another programming environment. In a future video, we will see how to use animation mode with nested macros.